last 4 or 5 years, as I was sort of talking about in my speech, that we've gone through a bit of a change at MessageMedia in terms of rebuilding everything that we've got into this nice distributed microservice type architecture. And at the start, we kind of wanted to be DevOpsy, and we talked about it a lot at work, but we didn't really know how to get there. And it kind of got put on the back burner, and as we built out this new platform, we realised that enabled us to practice a lot more of the DevOps principles and get them embedded in how we work. So it wasn't a direct choice to go DevOps, so to speak, but it came about from changing the way we work and changing how we deliver our software to our customers. DevOps Talks is a really good place to come and share that with a lot of other companies and people who sort of want to understand a bit more about what it actually means to be DevOpsy and share some of our learnings and understanding. But also at the same time, it was good to bring along some of our staff to come along and listen to the other talks and have them get a different perspective on what it means to be a DevOps type organisation and learn some things that they can bring back to us and help us improve as well.
So our next speaker is Ben Mostafa. And Ben is an engineering manager and head of developer relations at MessageMedia. He's leading the team responsible for building, executing, and supporting the API products supported by MessageMedia's platform. Ben has led the transition from monolith to microservices over the past 4 years. In his talk, Ben will outline the crawling skeleton methodology when building a microservices-based system and how you can adapt this methodology within your organization. So please welcome Ben to the stage.
Thank you. Good afternoon now. Does anyone use the SMS app outside to order their coffee this morning? Yeah, cool. How many microservices were involved in sending and receiving those messages, do you think? 27. A little bit lower? 16, cool. So 18 microservices were involved in sending and receiving those messages through our platform. So today I'm going to talk a bit about how we transition from our monolith system into a microservice-based platform, and the methodology that we used and applied to actually make that a successful transition. So a lot of us here, will be either very early on in our DevOps sort of journey to enlightenment, I guess, or some of us might be well on the way and have DevOps practices really well embedded in our organizations. But the fact is that we're all here so that we can help our businesses deliver more value quickly and with less resources. Many of us would agree that complexity and fragility are the mortal enemies of the illities that we strive to achieve when we're engineering our solutions. So things like maintainability, scalability, availability, and reliability. They all tend to break down when we have complexity and fragility within our systems. Adopting a microservice-based platform is really going to go a long way to helping you kickstart your DevOps journey if you haven't already. And if you haven't, if you're using DevOps types principles within your organization, a microservices-based platform is going to really help you derive some of the benefits that you get from having those principles within your business. So microservice-based systems can be complex and fragile. And what this crawling skeleton methodology aims to achieve, it tries to help you mitigate the risk and those issues with complexity and fragility within that system early on in the process of building out your platform. So it's going to help you reduce that complexity and fragility by engineering those problems out of your system early and finding those faults, fixing them, and then moving on with developing what you're going to build on that platform. It enables you to build stakeholder confidence in your project and your team and the teams that you're working with. So throughout this methodology, you're continually capturing data and feedback on how your system is performing, and you can then feed that up, down, and within your peers and help build confidence around what you're working on with that data saying that yes, what we're building is going to meet the requirements, and here's the facts behind that. Later on in that process, once you've got that platform really well established, you start to see benefits in the speed at which you can deliver value to the business, new features on top of that platform, as well as the quality. You'll start to see improvements in the quality of what you're delivering. There'll be less defects flowing out through into your production systems. And the teams that are working on it will find it easier and more, they'll be better able to rationalize what changes have been made to the system and what's happening within that platform. So there are a lot of systems out there that really do help you spin up a microservice type system quite well, and they do a really good job of that. But what some of the things they don't do and what this methodology is intending to do is to help you deal with those complexities and issues that arise when you're joining your platform together. So when you're building out 5, 10, 100 microservices together, that's when you start to see a bit of complexity and issues creep into your system, and this methodology aims to get those out and dealt with early on. So who is MessageMedia? We are a business messaging company, and we provide an application-to-person type messaging service for our customers. So what I mean by that is one-time passcodes, two-factor authentication messages, marketing messages, appointment reminders, all those messages that you get on your phone from various businesses. Our platform powers all of those messages. We've essentially got a platform that's connected into all the carriers all across the world, and then we provide an API layer on top for developers to build applications on top of. We have seen an increase in our message volumes over the last few years, and in this very accurate diagram here, you can see it's really started to pick up recently. And as that happened, what we started to see around that sort of spike was that there was some real breakdowns in the way our monolithic, or our original platform could handle those messages flowing through it. So we're seeing issues where there was constant incidents when message volume spiked from our customers. We would see issues where load on the system would cause back pressure and push back pressure down to our API clients. So things like timeouts and connection errors would be quite common for our customers, which wasn't great. Deployments were scary. We didn't want to deploy things because we knew that we'd break something, which wasn't a good place to be in. And something that we sort of realized in hindsight was that as we scaled out and built out this microservice-based platform, we really saw an increase in the scale in which we could build out features on top of that. So previously, we would sort of add more developers and more resources to build features and improve what we had, but we didn't see the expected returns in terms of what we could actually deliver with those bigger teams. With this distributed type system, we're able to sort of scale out the things that we're delivering and building as well to really provide more value to the business with less resources, I guess. So I'm Ben. I work at MessageMedia as an engineering manager and also head up our developer relations program. And over the last 4 years, which was the time frame on that graph, I guess, I've been helping to transition the business, the platform that we run, from a monolithic type platform to a microservices-based architecture. And today I'm going to quickly explain to you what that methodology is and then how we applied it and give you some tips and tricks on how you can apply it to something that you'll be working on. So to start with, it's a methodology that's based on DevOps principles. So it takes those 3 ways and seeks to embed those in your organization and really practice those when you're building out your platform. So the first one is flow. So this methodology helps to increase the flow of work that's getting put through your system and help you work to deliver that value from the very start all the way through the end of your life cycle to where you deploy it into production. It also encourages tight feedback loops. So when you're pushing changes out and building out your platform, it encourages you to do that in a really short iterative way. So you make a small change, push that change out, test it, and then iterate on that and build on top of that. And with that iterative approach, it really encourages continual learning and experimentation. So you make a change to your platform, push that change out, work out how it affected it. Was it a good effect? Was it a bad effect? And then iterate and change and experiment and try different things. So it breaks down that implementation of your system into 3 phases. The first one being the crawling skeleton, second one being the walking skeleton, and the final one being the running skeleton. And where that skeleton analogy comes from is that you can consider one of those microservices in your platform as a bone. And when you string a whole lot of those microservices together to create your platform, you end up with what you call a skeleton, because all those bones draw them together and create this skeleton. So how to go about it and how we went about it. So there's a slide I didn't put up here, which is essentially step 0, and that's to define the architecture of what your microservice platform is going to look like. And in that, there's also a lot of domain modeling that you need to do. So working out, you've got this big set of data that represents all of the parts of your system. And you need to break that down and encapsulate that into microservices to keep that separation nice and clear. I won't talk about that too much. There's a lot of reading you can do about all of that. And it really pays to invest a bit of time in that architecture up front. But again, it doesn't have to be perfect. You can change things along the way. But it serves as a really strong starting point for what you're going to build. Oops. So step 1, which is up here now, you need to decide what your stack is going to look like, what programming language you're going to use, what application containers it's going to run in, your logging infrastructure, your metrics, and then all the way down to how you're going to deploy those microservices out into production. After that, you've got to think about the communication mechanisms between those microservices. So when you've got all these distributed systems talking to each other, they're going to need a way to communicate. And you've essentially got 2 real choices to make here. Are you going to go with a synchronous type communication pattern, or you're going to go with an asynchronous type communication pattern. So synchronous being HTTP requests, potentially over a REST API, or asynchronous using a message queuing system where you pass messages onto a queue and other services consume from those queues. With the HTTP type pattern, it's typically a bit easier to implement. There's less things to worry about, and it's usually better for maintaining transactional integrity between two services. So when you make a request to one service, it will respond with success or failure, and you know that that transaction has been affected and what the result was. With the queuing-based system, and this is what we really use quite a lot in our platform, it's typically better at dealing with spikes in traffic. So when you get a big flood of requests, or messages in our case, they can sit in the queue and be processed and not overload any downstream services. They're also a little bit more fault tolerant as well. So if one of those downstream services goes down or stops responding for a while, those messages or transactions can sit in a queue and wait until that downstream services come back online, and you won't be losing requests and you won't be putting back pressure to your client saying the system's down. So once you've decided upon those patterns in your stack, it's time to go ahead and create that first bone in your system. And essentially that's a really bare bones, almost a template of what your first service is going to look like. And it's going to contain what, the essentials that you need in that first service. So if you're using HTTP, it's going to typically be a web server. And if you're using a queue type interaction to talk between the services, it's going to have some logic there that will publish to your queue broker or to your queues and then consume messages from your queues as well. You put things in there like your application containers, your logging, your metrics, and all of the deployment steps that you need to push it out, so your CloudFormation or whatever you're using to get your code out to production. Once you've got that first bone in place, actually push it all the way out to production. Again, it's not going to do much. It's got no business logic in it. It might just have a log line that says I received a request or I published a message, and that's it. Push that out to production or a production-like environment, and then put some load through it and test it. Make sure it behaves as you expect. Everything should work fine at this point, but it's really good to watch those metrics and capture all of that, and that's sort of the first data point I was talking about that will allow you to feed back information to your stakeholders. So back in step 2, when you create your first bone, it's a really good point then to actually instrument as much as you can in terms of metrics on HTTP requests received, response times, queue publishing rates, queue publishing times, and all that kind of stuff that you'll want to use and see throughout your whole system, because this bone is going to form the whole system essentially. So as much as you put in here now, those benefits will then be paid off when you start to replicate this out across the skeleton. Again, put load through it, capture those metrics, and make sure it behaves and works as you expected. Once you're happy with that first bone, then it's time to start wiring all that up together to create that skeleton, your crawling skeleton. So put together all those services in the pattern that you want, according to the architecture. Connect all those things together, so you'll have to start to pass in queue names into your services now, or endpoints of other services that service will need to talk to. Configure all of that up and essentially get your first skeleton or your crawling skeleton ready to go. And then again, deploy that through to production. So again, no business logic here, no real downstream services, databases, anything like that. Just really basic workers all wired up together really well. And then put traffic through the system. So on the diagram up here, we're using JMeter to publish messages or push requests into the system. And then we're capturing all the metrics from all those services into a central point. And now, if you put 10 metrics in your first bone, and you've got now 7 services in your skeleton, now you've got 70 different metric points that you're going to be collecting and analysing when you're running one of these tests. And you might see differences in behaviour to that first bone when you've now got 7 or 8, 10, 100 microservices all wired up together. So a little trick not a trick, but something that we learnt, one of these unknown issues that we found along the way. That first bone worked really well at publishing and receiving messages from a queue. It was really, really high performance, nice and fast, which is something that we care about. Latency is a core part of our system, or low latency, I should say. And that first bone worked really well, but then when we scaled it out to 10 or 20 different workers reading and writing to queues, we started to see a drop-off in performance. So just hit a cliff when we sort of put enough load through the system. And because we had nothing else going on, it was just literally a series of workers passing messages through to each other, we found this error. And this error was really easy to find. There was an issue with the ZenNet drivers on a specific instance type that we were using. And because the system wasn't really doing anything yet, we're just testing out the publishing consumption from queues, we were immediately able to determine what was causing this issue, switch out those instances for a different type, and then just rerun those tests again. So this was a fun issue that we found. It was probably the best example of something that we'd never sort of would have happened when we first put together that architecture. But finding this really early and dealing with it in a really easy way and getting that fast feedback loop of what broke and how do we fix it was a big win for us. We don't like finding these problems, but it's better to find it early on than later when you've got traffic running in production. And then once you've nailed out all those issues and flushed out all the problems with that crawling skeleton, then you can start to get that skeleton to stand up and walk. So at this point, you're adding business logic to your services, you're adding databases, calls to third-party APIs, and all the things that actually add value and make your service or platform do what it needs to do. So build all those in. You can build them as small and iteratively as you like, or you can build a whole lot out at once. But as you do that, every time you do add a new feature or a new bit of business logic, repeat those tests. So deploy what you've got all the way through to your production-like environment. Again, testing that deployment path as well, making sure that's all well bedded in. And then put load through it. At this point, you're going to have even more metrics coming out of your system now because you would have instrumented some of the business logic in those services. You might have more metrics coming out from the databases that you're connecting to or the third-party APIs that you're calling out to. Put load through the system, capture all those metrics and see what breaks, see what doesn't work, see what doesn't perform as you'd expect, and fix those issues. So change something, add a new bit of business logic, run your tests, fix it if it needs to be fixed, and then move on to the next part. And essentially, when you get to this point, you've got your walking skeleton. Now you're starting to teach it how to run. So add a bit of business logic, add some new features, put load through it, deploy it through to production, and then put load through it and test it again. As you keep repeating this process, again with your tight feedback loops, you're going to start to find more and more things that need to be fixed in your system. And finding and fixing those things earlier is much better than finding and fixing them later on. And at this point, you're just getting that skeleton to run. You've got your walking skeleton, and he or she is happy doing what it needs to do. And now we're going to get it to a point where it's really performing as expected. So again, you're capturing metrics. You're feeding that out to your stakeholders. You're building confidence that what you're building is going in the right direction. It's going to meet the requirements. And at this point, you're doing things like adding caching layers to points in your system where there might be bottlenecks, talking to downstream data services. You might be looking at scaling up or scaling out your instance types that you're using as well, so you can get the correct amount of performance out of your system. And at this point, it's really nice to be able to actually run different tests and see what instance sizes or what configuration best meets the performance requirements that you have, and also being able to work out how much that's actually going to cost to run in production. You might also look at changing some of your data access patterns in those services, profiling some of the code that might be not performing as you'd expect as well, and just iteratively tuning and improving that system until it's at the point where you're happy with it. Now again, remembering that premature optimization is the root of all evil, as they say. You kind of just want to fix one problem and then move on to the next one. So you don't want to try and fix everything at once. Just put traffic through the system, find any problems, fix it, and repeat. Just keep repeating that cycle. And the more you do that, the better you're going to get an understanding and really working out how best this system's going to behave in production. So some of the key learnings for us are queues are really worth the effort. So for our system, where it's low latency is really important, as well as reliability. So we don't want to be losing messages flowing through the system. Using queues, which typically are a little bit more effort than perhaps a client-server type pattern with HTTP, really helped us, and it was really worth the effort to make sure that system was really low latency and really reliable. Dead letter queues are great for recovery. So what we did was that in each of those services, and this is something that we built into that first bone, was that we added a dead letter queue. And what that means is when a transaction failed or there was some problem, maybe an exception that we couldn't handle, we'd drop that message or that transaction into a queue, and that queue could then be manually read by an operator or automatically read by a system and reprocessed later on once we'd fixed that fault in the system. So it's a nice little way to hive off problem messages or problem transactions, inspect them, work out what's wrong, fix it, and then replay those messages through the system again. Use an event stream. So another change that that happens when you go from a monolith to a microservice-based system is that you've got all these different services doing different things all spread out across the system. And again, this is something you can build into your bone, and this is what we did. Every service had a channel where it could publish an event or something about what it was doing every time it performed the transaction to a data stream. So using something like Kafka, you can just publish all these events into this stream, and then using systems that read from that stream, you can then analyze that data to see how your system's behaving, see how it's performing, and really just understand what's going on in production. Because everything's distributed, everything's all happening really quickly, and being able to capture all that in a consistent stream and then analyze that data later on is really powerful. You're going to come up against unknown unknowns, and that's the idea of this methodology. It's all about trying to flush out those problems and find those things that you didn't expect or didn't anticipate early on, get those fixed and resolved early on in your development lifecycle so that later on you can be building value-added features on top of that without having to worry about these issues popping up. And then finally, transaction IDs are really great for traceability. So every message that goes through your system, every transaction, when it first comes in, give it a unique transaction ID, and then log that transaction ID throughout every service that touches that transactional message. And again, you can build that into the first bone that you build. So when you're writing the logic within your application that logs to wherever you're going to log, build in some code that will grab the transaction ID from each message and include that in the log message that gets written. So every time a developer adds a new log line, it's automatically got that transaction ID in it. And then you can search your logs for that transaction ID and see everything that happened to that individual message or transaction, making troubleshooting and traceability really, really easy. So to summarize, and it's cut off a little bit there, I think, but you want to mitigate the complexity and fragility early with this methodology. That's the idea of it. It's based on DevOps principles, and it's a 3-phase process where you break up that implementation of your system into 3 chunks. You're crawling, walking, and you're running skeleton. And essentially how you do it, you create your first bone, string it all together, add some meat to it so it can stand up and walk, and then teach it how to run. At each step, you're testing, you're improving, and you're learning and getting some feedback about how the system performs, and then feeding that back into your development team and getting them to make changes to the system to improve it. So I'd like you to sort of think about, are there any systems that you're working on or things that exist in your organisation that could benefit from this approach? And what is that going to look like for you? So what does your crawling skeleton look like? What does your walking skeleton look like? And what does your running skeleton look like? And what would you do to get your skeleton to run? What are some of the things that you'd be adding at that last step to really get your system to perform as well as it could? If you'd like to ask any more questions, I'll be here for both days, or you can get in touch on LinkedIn or through our developer channels online. But that's really about it. So I'm going to hand over to the questions now and see what comes up.
Thank you, Ben.
So for our metrics collection stack, I'll kick off with the first question. What metric software would we recommend? So we're using Java. So we used a Java library, and I've forgotten the name of it, but it's a really powerful library where you can instrument all of your code. CodaHail is the name of it, or that's the author. And then we publish that out via JMX, and then we've got Datadog agents running on all of those services, which capture all those JMX metrics, or reads it from JMX, and publish it off to Datadog. So that's how we capture most of our metrics. Through those tests, what we also did was we wrote some custom tools that would go to Datadog, pull down a whole lot of metrics that we cared about. It would go to our Amazon system and pull down a whole lot of metrics from there about the CPU and the memory and disk and network usage of all those systems, and then aggregate it all into one place and just display a graph, a time series graph of here's the CPU of all the machines, here's the latency of all the messages flowing through, here's all those JMX metrics that we're pulling out of those instances, and display that on one big page. You scroll down, and as you're running those tests, you'll typically see at some point when the performance became an issue, one of those graphs or one of those data points will be showing you what's happened and why. So it might be, for one of our cases, it was the provisioning of DynamoDB tables. So we use that quite heavily in our system, and we had to work out what the optimal provisioning was for the read and write capacity. We didn't want to over-provision because that's going to cost us money, but we didn't want to under-provision because that's going to hurt our performance. So we'd monitor the provisioning of those systems, and we'd then upgrade or downgrade the provisioning as necessary. And just pulling that out of AWS's metrics system, CloudWatch, we can then display and aggregate all that together. So Datadog, Amazon's CloudWatch, our own handwritten tools to pull data out of JMX, and that CodaHail library I spoke about with Java really helps, and we tied all that together to get the metrics out of our system that we needed. How do you break a monolith legacy service? Ooh, nope. I'll go that one first. How do I break a monolith legacy service into microservices? Is it worth it? So I guess how to is kind of described in the steps through there. And is it worth it? Yes, when you need to. So I wouldn't go straight to a microservice-based system straight away. There's a lot of extra effort and complexity and fragility that you get when you go down that path. So don't do it straight away. But when you get to the point where your system just can't perform what you need it to do anymore, when the scale starts to cause it to break down and your incidents are outnumbering the features that you're delivering, then it's time to think about breaking it up and splitting it out into a microservices pattern. And that's effectively what we did. We got to that point where the scale of messages that we were delivering, we just couldn't cope with that anymore, and we had to say, let's split this out and break it down so we can scale it and manage it much better. Some of the 18 microservices used in the Coffee app to give us an idea of their scope. So when I said the 18, that's not including the Coffee app. Essentially, that app is just a couple of Lambda functions, which when you text in, it goes through our platform, and then we publish it off to this Lambda function. And that platform is where the 18 microservices are that I'm talking about. Our system has an API for sending messages, but also it provides webhooks for receiving messages. So when you text in, that gets pushed out to a Lambda function we've created, which puts coffees into a table, and then they're read out to the barista. So there's 18 microservices exist within our platform, and then any applications that sit on top consume and use that platform via the API and the webhooks that we have. Happy to chat about some of those microservices after this if you want to come and learn more information about what's actually inside there, but I won't go into that detail at the moment. How do you handle testing that different combination of version microservices work as before deploying? So testing is, again, more difficult when you've got lots of different services that you're sort of wired together. Testing it was essentially we would upgrade the whole stack with just one feature and then run those tests again and make sure that, again, in those metrics, one of the things we did capture was the version of each service that was being tested at any one time, so we could track that against the results as well. I can't really go into too much detail more on that one as I wasn't part of the testing team, but one thing that was really important as well, we've got all these messages passing through the system, and when we were upgrading versions of one service to another, and other services were still at the older version, it was really important to have a version on each message as well of the schema of the data that was passing between those systems, so that then if we deployed a new version of a service which couldn't deal with that old schema, or it had an upgraded schema, you could then check the version in the metadata of that message, not so much the body itself, and reject that message and leave that for an older service, older version of that service to deal with. Time's up here. Should I keep going with questions or wrap it up?
Maybe one last one.
One last one? Cool. What software do we use? So we've got a number of handwritten tools that we use for pushing messages into the system and then tracking those messages successfully came out the other side. We call them simulators. Essentially, they simulate our customers' behavior. So they're all handwritten tools that we've written which interface with our API. And then at the back end of our system, where we typically interface with the carriers, we simulate what their interface looks like and pull messages out of the system that way and check that we sent a message in, it came out the other side correctly, and this is how long it took. We use JMeter quite a bit as well for just pumping messages into a system and flooding it and getting it to work. But yeah, most of it's all handwritten type tools that we decide we write as we need to. I'll be here all day and tomorrow, so if you've got any more questions or want to talk about that more, come up and have a chat.
Awesome. Thank you, Ben.